Okay. So fingers crossed everything's recording like it's supposed to. All right, so this week's a short week. I am gonna go ahead and do the PowerPoint. I'm gonna do a live with you Wednesday. Thursday and Friday, y'all are gonna go off and have a long weekend and enjoy yourselves and pretend that we haven't done computer science. I am. Monday, I'm gonna treat it like I would your Friday workshop. So I'm gonna answer questions and stuff like I normally do on a Friday of the following, a week from today, will be a workshop day. I'll introduce your project 2 on that Wednesday. You'll have the rest of that week and all of the week after in class and at home to work on project 2. Now, I'm gonna say this out loud and clearly for everybody. I do not give you almost 2 solid weeks to work on a project that you can finish in one afternoon. Let me say that again for the procrastinators in the room. I do not give you 2 solid weeks to work on a project if you can finish it in an afternoon. So don't wait till the day before to start something. Now, are we starting it this week? No, but I just want to get that in your head because I can't tell you how many people emailed me after the original due date, because I pushed project 1 back a few days. Said, oh, I just started this. Okay, good luck with that. Now, again, this next project coming up will be done in 3 parts. You can do part 1 and just turn it in, or you can do part 1 and 2 and turn it in. You can do all 3 parts and turn it in. Use your time wisely, but don't wait till the day before to start it. All right, so today we're going to do while loops. The good news about this particular section is you've already read the chapter in guidebooks on loops, which included for and while loops, if I'm not mistaken. So there's no new reading for this week. You might want to go back and look over some stuff in guidebooks if you want to, or if you feel like you need it on the while loops, but we're going to do while loops. Why do I split it up this way? Because while loops makes so much more sense if you've already had ifs. So in the future, when I rearrange this class, I'll probably will teach ifs first and then do loops, but 6 of one, half dozen the other, which order you do it in. So we're going to talk about them. We're going to use them. We're going to do stuff with them. We're all happy. No, okay, maybe not. All right, moving on. So let me get this slides going. So last class, our last new thing we did was if statements with Boolean functions, and we tested for boundaries, right? Above, below, equal to, whatever boundary. Well, while loops work on the same kind of concept. So instead of having for loops were counting loops, so it counted up to a point. It was in a range, or you had a set number you were going to do it. So we also did random numbers on this last project, so we're going to talk a little bit more about them. I made you go do it on your own, made you do some research. So we're going to clarify some stuff on that if you didn't get the random color going from part 3. So the random module, you used it. It's used a lot for games and simulations because it makes games harder if it's randomized, right? They're all asleep. Okay, that's it. I'm over that. Random numbers in computers are not truly random. For our intents and purposes, they appear to be random. They call them pseudo-random. The reason they're not truly random is because they're usually based off a calculation that has to do with the clock speed of your computer, which is done in nanoseconds, and it's computed from there. So for a human whose brain and conscious thought doesn't go in nanoseconds generally, it seems very random to us. If you knew exactly what clock cycle you were on when that random number was calculated, you absolutely could figure it out. You don't have to use another computer to do it. But so that's the reason we say it's pseudo random. You could theoretically figure out what the random number was if you knew the exact clock cycle it was on when it was generated. And you knew the formula that that programming language was using. Does that make sense? Because it's a computer. It doesn't, it doesn't truly have that random ability. Because AI is coming, but right now it doesn't think for itself. The random API you all should have found if you did part 3. We generated a random. You can just generate a random with no guidelines. You can put a starting point, a stopping point. So you want a random number between 1 and 10. You would put 1 and 11. If you want it to skip steps, you can put in the steps. The steps is in the square brackets because it's optional. You don't have to actually give it steps. If you don't, that's fine. If you do, it'll skip a certain number before it picks a random. If I'm not mistaken, and I'll have to test this, the first number is inclusive. So 1 would be included if you did 1 to 11. If the second number is not included. Don't ask me why they do this on several different places in Python. It does. Sometimes it's inclusive, sometimes it's not. We just have to test it and make sure. It does it with string functions and stuff too. So we're going to add something to our loop section because we talked about function calls, we talked about loops, and we talked about conditionals. So now we're going to add a while loop with our for loop. So somebody's like, why do you need 2 different types of loops? Could you do it with a for loop instead of a while loop? Yeah, most of the time you can. While loops are very helpful if you don't know how long you need that loop to last. Say, for example, you're playing a game. And you have a menu that pops up, and you have to select from the menu. Or if you think about all those phone calls you make where it says press 9 to exit, or So that could be done with a while loop. Because that loop's going to run and keep popping up until you press the 9. And it can't predict when you're going to press 9 to exit. Or whatever the stopping point is. Because we're humans and we're unpredictable. So it's while I'm not getting the exit one, I'm going to keep going. So I covered that already. So here's some logical while statements. You can't really code these, but there's some logic for you. A while loop is, I'm going to keep eating while I'm hungry. So if hungry equals yes, I keep eating. Otherwise, I stop. I wish I had that much self-control. When you're scanning on your car or your radio, you press the scan button, it's going to keep going and popping through radio stations and finding the next station until you tell it stop. So you hear what you want to hear, your favorite song. And that might be a little outdated for some of you guys that use satellite radio and music apps. But us old folks used to hit the scan button until we heard what we wanted to hear. Your car still has it. Yes, for real. Most modern cars still have a scan function. I feel old. I still feel old when I talk to you guys. So in that case, you would have a while loop of what, while I do not like the current radio station, I keep moving. When I like it, I stop. So here's a example of pseudocode. It's mostly code, but these are not functions that actually exist anywhere. Nobody's written them, right? So I'm going to define a function that scans for radio station. It's going to find a radio station. The current station equals get current station. This assumes that all these functions exist. But it gives you the format, right? So while not like radio station, current station, keep going. So we talked about nots, right? If I want to negate like, I put not like. Let's do it with turtles, because that makes more sense to me, right? We'll play with turtles. You all should be turtle experts after that drawing you just turned in for me. So I can take these lines that we know from reading it makes a box, right? Because we've drawn a lot of boxes at this point. And we use a for loop when we did it, right? You also could do it with a while loop. Where did my turtle slide go? One of my slides has disappeared. Okay, it happens. You also could do it with a while loop, and you could change the for loop. Instead of for I in range 4, you could put while I is less than 5, right? And it would go 4 times still. Or you do less than equal to if you wanted to put 4 in there, right? I hate it when my slides lose a slip. So the way it generically looks like is the keyword while, then the condition, what we're testing for. You need to test for something that's going to be a Boolean again, true or false, and a colon. Then everything that it wants to execute will be indented in. I had a lot of code. Now, I haven't read the project yet, obviously, but when we did the buses, a lot of code where people wrote the proper code, but it wasn't indented properly, so it didn't belong to the correct functions. Can't tell you how many I went in and grabbed whole sections of code and either increased or decreased the indents. I can't tell you how many functions had 6 other functions defined inside of it because they were indented in too far. That makes it very hard. And I was nice. I graded them. I fixed them and graded them. So here's an example in code. So while loop is less than 5, I'm going to add 2 to sum, and I'm going to add 1 to loop. And when I'm done, I'm going to print out sum. Now, here's the thing. I like for loops because all of it's done on one line. Your variables incremented all in the one line. You don't have to worry about that. While loops don't work that way. They have the test. And as you notice, I had to declare a variable I had to declare the loop variable up here, right? And then I use it here in the test. And then down here, I had to actually explicitly to tell it to go up by 1. So a for loop handles all 3 of those things on one line. It's part of its structure. A while loop, you have to have all 3 pieces set up, and you have to set them up correctly. If you define your loop variable after the while, you're going to have a problem because it can't check it the first time because loop is not declared or has no value. if you forget to add one to loop, guess what? Your while runs forever, and you now have what we call an infinite loop. You're like, it's not doing anything. Yeah, it is. It's just doing that loop over and over and over and over and over and over and over again. Right? So there's 3 parts to a while loop that you need to keep up with. You have to declare your variable. You have to set up your condition. And then you have to increment or decrement your variable. Increment is a fancy word for add to. Decrement is a fancy word for subtract from. So some loops count down. Some loops count up. However you program. So if I did this loop and I ran it, what am I going to print? What is sum going to be when I get to the print line? Come on, math majors. Less than 5. Okay. So the first time through, sum is 0. So on the 0 iteration, we're going to add 2 to it. So now sum's 2. On 1, we're going to add 2, and now we are 4. You may be right, maybe 10. Because I forgot the 0. 2, 4 on the second one. On the third, on iteration 2, we're at 6. On iteration 3, we're at 8. And on iteration 4, we're at 10. Right? Don't forget to start counting at 0, like I just did. Right? Now, could I have set loop equal to 1 and got 8? Absolutely. That's the great thing about while loops. Since you're setting up the counting starting point, you can set it up, start where you want to. You also can a for loop, but we didn't talk about that a lot. But in Java, it's really easy to change the starting point. So if I did a for loop, it would look like this. A lot less lines of code, right? I don't have to keep up with as much. Guess which one I prefer? If I can, I'm using a for loop. Because I learned a long time ago when I was early programming that I sometimes forget to type lines. Now, does that mean that you can use for loops in the assignments for this week instead of while loops? No, because we're practicing while loops. Just because you know some better way of doing it doesn't mean you get to use the better way. And there are still places that you need a while loop instead of a for loop. So let's go back to our turtles because we all know about our turtles. While is in screen, passing in a turtle in a window. So basically this is just from reading the name of the function, I'm going to guess this is going to tell me whether or not the turtle is in the screen. And while it is, I'm going to keep doing something. I'm going to set up a variable called coin. I'm going to use the random from 0 to 2 because a coin only has 2 choices, right? Either heads or tails. Somebody's going to say, oh, well, that's 3 numbers. Oh, remember, first one's included, second one is excluded. So the 2 is not included in the range. It goes up to 2. So I have 0 and 1. If coin is equal to 0, the turtle is going to turn left. If the coin is equal to right, sorry. Otherwise, if I don't have any other test, otherwise we're going to go right. Left on 0, right on 1. Basically what this loop says. And then after it's made that choice and turned, then it's going to move forward. So guess what this is going to do? This is going to help us randomize directions for our turtle. And I'm going to give you some code before you get to the lab. So don't get ahead of me because I think my links are gonna be broken on some of this because my link was broken last week. The formerly free online textbook I was using seems to have moved. So I'm gonna give you code when we get ready to do this, so be aware. So we're gonna write a little lab that's gonna have our turtle doing some random movements. And it's gonna keep going until the turtle touches the edge of the screen. That's the reason we're using a while loop. You can't use a for loop for that because since it's randomly turning, we don't know how many steps it's going to take for it to get to the edge of the screen. So this is a case where a while loop is needed because a for loop's not going to work for us. I'm glad you got it. Thank you. I appreciate the feedback. All right. Infinite loop. This is an infinite loop. Why is this an infinite loop? It does go on forever, hence the name infinite loop. What piece of code is missing? Yeah, the loop plus one is missing. We never change the test values. If this value never changes, it is always 0. Then loop is less than 5 forever. Now, this is also easy to mess up if you got the greater than and less than signs backwards. Even if you're adding 1 to it every time, if you got that backwards, as long as it's greater than 5, it's going to keep going to. You know what I'm saying? While versus fors, like I've been saying, while loops are suited for situations where you don't really know what the stopping value is. You know you have a condition to stop, but you don't know how long it's going to take you to get there. It could be 1 or it could be many steps. For loops are suited for executing something a specific number of times. Drawing boxes, for loops. Drawing hexagon, for loops. Hexagon only has 6 sides. We know we're going to do it that way. Right? Infinite loops are possible with both loops. In my opinion, it's easier to get infinite loop with while loop because you have to keep up with 3 parts individually. But you can absolutely get an infinite loop with a for loop by having a wrong sign in it, or incrementing instead of decrementing, or decrementing instead of incrementing. I do speak English most of the time. Questions? No, an infinite loop will not give you an error. Because the code is valid. It's a logical error. So it will run. But until you run your computer completely out of memory while it's running, you will not have any indication that you have an infinite loop, except that it's taking forever.
Is that what they mean when they say like stuff like memory leak?
Not exactly. A memory leak is more of an older thing from where you're not disposing of used memory properly. A lot of that's easier to do, easier to clear up now with the garbage collecting that you see in modern languages. You saw a lot more memory leaks in languages that had pointers where you had to declare and then undeclare memory usage explicitly. You still have them, don't get me wrong, but it's more of a, oh, I'm just going to keep storing these variables in over and over and over and over again until I use up all the available slots. Yeah. And back in the day when I was getting my computer science degree, that was something that happened more than we care to admit because computers had a lot less memory. Nowadays, your computers have gigs and gigs of memory. So these little bitty programs you're running would go a long time before they ever used up all the resources.
Gotcha.
Now, if you were doing millions of records in a database, you might could do it. You definitely can slow down a server doing it. Generally speaking, you catch an infinite loop when you go, this is taking too long. Something's wrong. And then you're like, and then you kill the process. What? Yeah, you can make it faster. We're not going to, but you could. Cloud computing will usually catch this. Sometimes we'll catch this for you because you're taking up too many resources or your bill goes way up. Because I don't know if you guys are aware of this, but a lot of the cloud services charge you for usage. So when you get jobs and working with AWS or Kubernetes or things like that, one of the things you're going to be asked to do is to optimize everything because the company you work for wants to pay for as few resources as possible. You definitely don't want an infinite loop running on a database that's stored in the cloud because you're getting charged for the process. Now I've oversimplified that by a lot, but that's a general concept. I'm also learning a lot about cloud right now because I'm teaching a course that has some cloud computing in it. So I'm going to skip these tasks unless you just really want to write some code. Input validation. Your goal on this or in your live production is to make sure that you force the user to give you valid input. So this is why I've been stressing that you should ask clear questions when you ask for user input, right? You also can use a while loop to force that. So you want the user to give you an integer value, a whole number, right? And it needs to be between 1 and 100. You can set up a while loop that keeps asking the question until the input that you get back meets the requirement. You ever been on a web page that just makes you keep filling out the form until you fill it out exactly the way they wanted it? Phone number with dots instead of dashes, no dashes, things like that. So you're probably using a while loop in the background that says, while this is invalid, ask them again. So you'll see a lot of while loops in user validation. We're going to eventually do a assignment where you're going to build a guessing game. And you're going to keep asking the user to guess a number until they guess the correct number. While loops. Oh, you've already guessed that number. Don't guess it again, kind of thing. While loops. So you also can set your loop variable to just true or false. So while loop, and loop is equal to true, so basically it says while true, well, it's going to run. And this very easily can become an infinite loop if you forget to change loop to false when you get what you're looking for. So you can just set your loop to true, keep doing this while true. And then when you get what you're looking for, when the value is in the range you're looking for, you set loop to false and the loop stops. You had a couple of people looking at me like I've got 3 heads. Questions? I probably do have 3 heads, maybe. Will this make more sense once we do the lab on Wednesday and you've seen it in action and practiced it some more?
Yeah,
Maybe, yeah.
Yeah.
Yeah, it usually does. Now you see the method to my madness. I give you a couple of days to sit on the theory, and then we do it. So I hit both modalities of learning. Those people that like to hear it and think about it, and those that like to do it. Huh? Does it work? Okay. Well, we'll try to come up with a different modality for you. All right, so this is another example. You can do a lot of different things. You notice in most of these while loops, there's an if statement. That's the reason I like to keep whiles after ifs, because especially if you're using them for validation and stuff like that, you need the if statement inside of them to check to see if the information was valid or not. If it's valid, I'm ready to move on. If it's not valid, I need to make this loop keep going. So remember, just because these concepts and these constructs have been taught in isolation, they absolutely can be merged together. So that's what we're moving towards for our next project, is that you're going to pull your loops and your if statements and your variables and your random numbers and your this and your that, and it's all going to pull together into a project. And I'm going to be honest with you, project 2 is the hardest of the 3 projects. Because project 3 comes at the end of the semester, and I don't want you to go into the finals week trying to build the biggest project of the semester. That seems cruel and unusual punishment to me, to add that on top of finals for the rest of your classes. I'm glad you decided that was a wonderful idea, because I try to remember that I'm not the only teacher you have. And like, y'all are on semester, so what, a full load is 4 or 5 classes? I missed quarters when it was 3. But y'all have other classes, you have other homework, you have other things to do. And I know mine takes a lot of time. So the major project is next. We're gonna get through this week. I'm gonna give you 2 weeks to start working on the major project. I'm gonna be honest with you, since we have these extra few days, that project could get extended. I could shift everything in a few days. Because obviously I left a week out. I've got a week to play with now. And I'm gonna be honest, I intended for that free week to be.
Free.
Well, I intended for it to be when we did the project, but everything. I probably was thinking that I should have swapped it basically for a week. But I build in an extra week to all my classes. If we get to the end and we're done, well, then we have an extra week to review before you take the final exam. But we also can use a few of those days for this next project if we need to, or the last project. There is one more project at the end. It's just not, in my opinion, as time consuming as this project, next project will be. But I swap them around and do the less time consuming one now and the other one at the end. Yeah, but like I said, just hate to do that to y'all during final 2. Or leading up to final 2. Because everybody's going to give you a test, everybody's going to give you a project, everybody's going to give you a final. So let's talk about Sentinel values. So Sentinel values are basically a value that is so far out of what you're expecting that if you see it, you know that it was deliberate, or you're setting it up to be deliberate. Like for our number guessing game, say I'm just tired of playing. I don't want to play anymore. I'm done. If I put in negative 999, I could use that as a Sentinel value that says, oh, my user wants to quit. So if I get that, I can change my loop value to whatever the quitting value is, or something outside of true, that makes it false. And I can stop. A lot of things have sentinel values. The Q on a computer game, if you got, a menu structure comes up, press 1, 2, 3, 4, 5, or Q, well, then Q is your sentinel value because it's not a number. It's something that you wouldn't accidentally press in the normal course of the game.
Unless you were trying to press one and accidentally press down the key.
Look, it's not something you're generally gonna make a mistake on. Pressing 2 instead of 1 is more likely to happen than you slipping down a row and pressing Q. So, and that's the reason a lot of people will make sentinel values something like -999. You're not accidentally on a single keystroke gonna get a -999, right? That's a deliberate choice. So that's a sentinel value. You can make just about anything a sentinel value as long as you define it in your code. And basically, inside your loop is going to be one of your if statements that if I get this value, I'm done. You see them in games, especially keyboard-driven games, a lot because they're useful. I know it'd probably be throwback games for you guys because y'all have all this high-end graphics and stuff. But those of us that grew up with games that actually were text-based, you saw this a lot. What'd you say? He's trying really hard to get on my bad side, isn't he? Calling me old and everything. It's okay. I am old. So this loop has a sentinel value in it. So it's going to read and sums values until the user enters -999. So when you get into your loop, the loop value is true. So this is going to keep running. And the only time loop gets changed to false is if value is equal to 999, -999. It's hard to say. Does that make sense? Does this give you an example of why you would use it? Do you have a question in the back or you're just checking? Just making sure. Oh. So lab 6 is what we're going to do on Wednesday. I actually am finished. The presentations from here on out are gonna, Mondays are gonna be short for the rest of the semester probably. Because we're gonna do the lab on Wednesday. I'm gonna do the whole thing with you. I'm gonna provide you with starter code. If you're in the online classes, I'll put the starter code on the website. It should already be on the content page, but I'm gonna check and make sure it's all working. So if you're listening to this video, I will be checking that this afternoon before everything goes live. Anybody else have questions or comments? Anybody super frustrated with the project and want to just vent? Now would be your time.
Well, this had nothing to do with the project. I feel like I'm playing the entire week. Things change and that's the world.
That's why I write in pencil.
That's not the problem.
That's my problem. I used to write in pen and then I would have to like mark out of it.
Okay, I'm gonna.
Actually, it was-
You